Alright guys, for our last video of the unit, we are going to be talking about line graphs. We're going to do a little project when we're done with this video and the activities that go with it, and then you're going to take your unit test and we'll be done. So line graphs are probably the most difficult kind of graph to both read and create, which is why I saved them for last. I wanted you guys to kind of get used to the idea of interpreting your data in pictorial form with graphs. But line graphs really aren't that bad once you get used to them and you understand them. So this is what our video is about, just learning the basics of line graphs. Alright, so first of all, our learning objective, and I want you to write basics on the left and everything else on the right. Write everything that is on this screen. You need to pause and write all of this down. So our learning objective, we're going to be able to read and create line graphs by the end of this video, or at least by the end of the time I give you in class to work on it. Your essential question is, can you think of something we would plot on a line graph by the end of the video? And then vocabulary, a line graph is a graph that shows how one variable changes over time. Okay, so just like with a scatter plot, we have two variables. One thing that's changing and your time, and we're seeing how the time relates to the change of your item. So just like a scatter plot, we're looking at two different variables, but the difference is that in a line graph, one of them is always time, okay? The x-axis in a line graph is always a unit of time. I cannot stress that enough. You must understand that line graphs and time are related to each other. You can't have one without the other. Alright, so line graphs versus scatter plots. Scatter plots are the most similar kind of graph we've seen so far to line graphs, but they're a little bit different. So if you look here at scatter plots, this is how height and weight are related to each other, and you can see this is of course a positive correlation because it's going up, like mo money, mo problems. And your dots are all scattered all over the place, but you look at the general trend. And you actually can draw a line in scatter plots, just like we learned before, that line of best fit. Now line graphs are different because you're connecting every single piece every dot that you plot to the dot after it and the dot before it, okay? So this is the number of dolphins that are seen in Santa Barbara Channel from 1996 to 2001. So if you look here, the x-axis is a unit of time. It's years, okay? So we look at the number of dolphins seen every year, and then this is the number of dolphins. So you can see from 1996 to 1997, it went way up. They saw way more dolphins. But then 97 to 98, they saw less. They saw a little bit more in 99, a little bit less in 2000, and then 2001 they saw even more. So on your map test, you'd see stuff like, what was the change in dolphins from the year 1997 to 2000? And you would just look at those 2 points and see how the number of dolphins changed. Okay, we're going to get more into that in class when we do these activities together. All right, so when you make a line graph, it starts out just like a scatter plot. We put dots where the two variables cross. We have to label our axes and everything like that. Remember, time is always on the x-axis, always. And then whatever else you're tracking is on the y-axis. So we put a dot where the two variables cross, just like a scatter plot. So this is Amanda's trip to Washington, D.C. This is how many miles she was from her home, from her starting place. Okay? So at 9 a.m., she was 0 miles away from her home. She was exactly at her house. So you put a dot where the 9 and the 0 intersect each other, just like we've been doing all unit. But then with a line graph, what you do differently is you connect it to the next piece of data. So at 10 a.m., she was just over 50 miles from her house. So you put a dot just a little bit above the 50, but then you connect that to the last dot. So when we connect all these dots, we can see how Amanda traveled as far as distance from her home to Washington, D.C. Now, if you look here from 11 to 12, she didn't travel any more from 11 to 12. All that means is that at 11, she probably stopped and took a break. So she traveled from 9 o'clock to 11 o'clock, she traveled just over 100 miles. And then at 11, she stopped. She probably stopped and ate lunch somewhere. So by the time 12 o'clock rolled around, she was still 100 miles away from her home. Okay, so that dot is still at the 100, even though now you're at 12 o'clock. That's why the line graph is flat right there, because the distance didn't change at all. And then she continued to travel on after her lunch. Okay, so just make sure that you connect the dots and that your x-axis is always time. When you read a line graph, if the line does not go up or down, just like I told you between the 2 points, that means that the data did not change at all over that period of time. So if you look here at this one, we're talking about how the temperature of water as we evaporate it, okay? So we're measuring time in minutes here. So you can see water is very cold here when it's solid, when it's ice. You learned that in Ms. Casey's class. It's negative 20 degrees here, but then we start heating it up and the temperature of the water goes up in those first 10 minutes. Now after 10 minutes, the water's melting, and as it's melting, see that? How the temperature stays at 0 degrees Celsius for those 10 minutes, but then it gets very hot over the next 10 minutes. So from 20 minutes to 30 minutes, it shoots up, and now your temperature is up here at 100 degrees Celsius. And then when it starts boiling, it does the same thing. It stays right here at 100 for 10 minutes, and it evaporates into a gas after 40 minutes. Okay, so anytime this line graph is flat, that means that whatever variable it is on the y-axis is not changing during that time. When Amanda stops and has lunch, her distance from home does not change. When the ice is melting or boiling, the temperature does not change. Okay, that's why the line graph is flat. It's really easy to understand line graphs if you create a mental picture. So if you actually sit here and look at this line graph and say, okay, I know that this is about the evaporation of water. I see solid, melting, liquid, boiling gas on here. I'm actually going to picture what it's like to melt a piece of ice all the way until it evaporates into gas form. Okay? So just create a mental image if you even have to draw a picture here. So whenever the temperature's going up here, you could draw an ice cube. Stuff like that. You could draw an ice cube melting, okay? And then water. Just do as much as you can with these line graphs to make it real and make a story out of it. And you're going to understand it a lot more than if you're just looking at the data on the chart. Okay? All right, so you guys have a great night, and I will see you in class.